Okay, this is an interesting problem as it contains the 6 root of x plus 2 and the 6 root of 4. And if you try direct substitution, you get 0 over 0, which is indeterminate, and you need to do something about it. The first thing that might come to your mind is you flip the sign between the 6 root of x plus 2 and the 6 root of 4 and multiply it and call it, well, quote unquote, the conjugate. All right, and multiply it up and down, so as if you multiply by 1, and you don't do something terrible to the expression, and you think that that should do the problem. So let's see what happens if we do that. Okay, in here I've just converted the radicals into powers, as you can see here. Right? Okay, and then I'll just multiply it by the same thing of the same as the numerator, except that I flip the sign here, and then I multiply it up and down by the same thing, as I said. And if this expression should reduce to the square of the first minus the square of the second. All right, so the square of x plus 2 power 1 over 6 is power 2 over 6, which is power 1 over 3, minus 4 power 2 over 6, which is again 1 over 3. The denominator will stay the same, which is x minus 2 times that expression which we multiplied by. Now, as you can see that we haven't resolved the problem, because if you do direct substitution again, you will get 0 over 0, which is also indeterminate. So what you need to do something else about it. Now, if you recall, if you want to factor the difference of two cubes, like w cubed minus z cubed, then that is equal to the w minus z multiplied by w squared plus wz plus z squared. This is a standard factorization. Now, if you think that this is w and this is z, then you only need to multiply by this expression in order for you to be able to cube them. And if you cube them as such, you will be able to get x plus 2 and 4 without the power 1 over 3. Okay, so now we realize that w is equal to x plus 2 power 1 over 3, and z is equal to 4 power 1 over 3, and the needed expression is w squared, which is x plus 2 power 2 thirds now, plus w times z, which is x plus 2 power 1 over 3 multiplied by 4 1 over 3, plus z squared, which is 4 power 2 thirds. So this is the needed expression for you to get something decent on the numerator. Okay, now this limit now can be written as the original expression multiplied by whatever factor we have decided on. Now, performing the multiplication on the numerator should retrieve w cubed minus z cubed, which is actually the cube of this minus the cube of this only. Okay, and the expression will reduce in the numerator to x minus 2. We should cancel out with the x minus 2 in the denominator here, and whatever is in the denominator will stay the same. Now all what you need to do is just direct substitution by 2, and the result is easily obtained. And of course you should be able to get the answer to the problem with a little bit of arithmetics. Okay, for this problem, let's as usual try direct substitution, and the direct substitution as x goes to 0, you will have the square root of b in the numerator minus 2 divided by 0, and that should, as told by the problem, should go to 1. Now, you realize that if the numerator is just a number divided by 0, number different from 0 divided by 0, then that should go to plus or minus infinity. You cannot just go to any other number. The only way that this expression can survive to 1, the limit be equal to 1, is that if the numerator is actually 0, and that gives an indeterminate form, and it is possible for that to produce a finite number. But if it is only a number divided by 0, then it's not possible. So the first thing here we realize is that the square root of b minus 2 should be equal to 0. Okay, and therefore the square root of b is equal to 2, and therefore b is equal to 4. Now, putting things back into the expression, then the limit this limit is going to be equal to the limit as x goes to 0 of ax plus 4 now for b minus 2 divided by x, and I will just as usual multiply by the conjugate here, which is the square root of x plus 4 plus 2 divided by the same thing here, the square root of ax plus 4 plus 2. Now the numerator should be the square of the first, which is ax plus 4 minus the square of the second, which is 4, divided by x, and then the square root of ax plus 4 plus 2. Now the numerator is supposed to be ax, and now this will cancel with that, and eventually x will cancel, and therefore you get this expression. X will go to 0 of a divided by the square root of ax plus 4 plus 2, and as you let x go to 0, then the result is going to be a over a over 4, but that limit is equal to 1, okay, as given by the problem, and therefore a is also 4, and therefore a plus b is supposed to be 4 plus 4, which is equal to 8.